Hi, this is Steve with OS Nexus, and in this video we're going to talk about designing storage solutions. Specifically, we're going to focus on highly available storage solutions using ZFS-based storage pools. And what we're going to focus on is the solution design tools on the OS Nexus website. And you can get to this, our web applications for designing these solutions by just going to osnexus.com/design. You can see that on my screen here. And just click the green button here that says Scale Up Solution Designer, and it will go and load the page. I've got one that's a little better sized for the video here. And so we're just going to go top to bottom, kind of explain what the different sliders are used for, and then we're going to go through an example configuration. We're going to talk a little bit about how do you design a solution for a use case like Veeam backups or a large-scale object storage archive. And in this video, we're going to, again, be kind of focused on the SAN/NAS solution design. I have a second video that we're going to do after this that's going to go into the object storage and the scale-out object storage design. So for this one, like Veeam backups will be a good one, and then VMware block storage, like setting up a SAN using an all-flash storage devices or potentially hybrid storage. So let's get started. So at the top of the design tool is a usable capacity slider, and this lets you select the amount of usable capacity that you need for your use case. So let's say that you're going to need storage for a petabyte of usable capacity. You just enter that amount into the utility, and it will automatically size everything that we do from here forward based off of the need for 1 petabyte usable. Now what we're going to do is choose a use case. What the use case selector does is it lets you adjust all of the other settings that are down below inside the utility. You can edit those after you've made a selection, and so we could choose something like large-scale cold archive, and you can see it redid the design for us to use triple parity and a larger stripe size, or we could choose like general backup and archive. This is a double parity based configuration that's really usable for a large, broad spectrum of use cases. So once you've chosen a use case that matches what you're intending to use the storage for, we can start to customize it. What we find is that companies generally want to continue buying the server storage from the vendor that they're already, or the servers that they're already buying from today. So if you are managing an IT environment that's currently using Dell servers, you want to be able to design your software-defined storage solutions around the same platform. And so that's what we have with QuantaStor. Is we've certified QuantaStor against a broad spectrum of all the major server vendor hardware, so that you can just go into our design tool and pick something that's already been certified, and the design tool automatically adjusts the configuration and updates that here in this lower section where it says server specification as we adjust these things. So here, if you wanted to do this based off of like HP ProLiant DL380s, we could just choose that, and it's going to adjust the server selection for us. The next, after you've picked the servers that you're going to use as the controllers, the highly available controller pair, you want to choose a disk enclosure. And again, we do a lot of work with all the major vendors to certify their enclosures against QuantaStor. QuantaStor does deep integration with the hardware. We're monitoring everything from thermals to power supplies to the mapping of the enclosure slots to the drive, so you can visually see a picture of the enclosure and the drive layout, so that when it comes time to do some maintenance, when a drive fails, you can go into that enclosure, find out exactly where the drive's at, pull it, and put a new one in. So anyways, let's pick out, we've selected the Western Digital Data 60 here. We could pick like the Western Digital 102. This is an HP server, so we could even choose like the D6020s, which is a 70 bay JBOD. And now we can choose the drive capacity. All of these SAN/NAS style configurations use external JBODs with SAS media. It can be SAS flash, it could be nearline SAS. Generally, it's nearline SAS and some SAS SSDs as well. So here you can pick the capacity of the drive. If we choose 14 terabyte drives, it's going to give us the greatest density. If we might intentionally choose a smaller capacity drive to increase the spindle count. So here, if I choose 4 terabyte drives, you're going to see that it now has added a second cluster in order to meet this demand of a total 1 petabyte usable. So keep in mind the configuration. It's going to redraw it and do all the adjustments and all the calculations for you as you choose different things within the design tool. I'm going to put it back to the 12 terabyte drive so we see this as one cluster. And now we're on to the write log devices. Write log devices are really important if you've got a workload that has a high IOPS demand, generally databases and virtual machines. Usually you're going to want to use all flash storage, but sometimes it's not economical to go all flash with your virtualization configs or whatever the use case might be. So the write log devices is a way to add SSDs to an existing or to a platter-based configuration to boost that write performance. And the way it works is as the writes come in, they are written to the log devices, and as soon as it's on stable mirrored log devices, it can complete the writes and then lazily write that data out to the platter storage. And this also lets it go and consolidate a whole bunch of small, like 4K, 8K writes into larger transactions to the disk media, making the overall IOPS jump that way as well. So if you've got an IOPS-based workload, you want to adjust this. Here, the slider goes in chunks of 2 drives at a time because it always has to mirror the all the writes. So you have to add those drives in pairs. So this would add 2 drives to each storage pool. And then the next one is the cache and offload. So for workloads like playback, video playback, say for a university that needs to go and play back a bunch of video content for all their classes, that would be a great example of a workload that could benefit from having some extra SSD in there as a large read cache. So as those students log in to go play the video for the class that day, or for say for remote learning or something, they would then, as the more and more students came in, as soon as there's multiple reads to that data, it would eventually find those blocks would be automatically put into the SSD and flash layer, and now you've got this boost in performance. Now it doesn't need to go out to the platter to go and serve that video content. It's considered hot data, and so now it's moved its way into the flash tier. And you can add as many of those devices as you like. Typically 1 or 2 will be sufficient, but if you add several, then you'll have a faster and faster read cache. The other part of this is that you can use some of these devices for what's called metadata offload. And this is a really important factor for improving overall performance for these parity-based RAID configurations. And especially it boosts write performance. And the reason why is that when you go and write a big block of data, it's going to need to write a small bit of metadata for the file system. And that might only be 4 kilobytes. Writing 4 kilobytes across a bunch of platter devices is not very efficient. It has to seek the heads, and at the end of it, it's only written a small bit of data. So you've got all of these various challenges that you have there. You've got maybe a big ingest stream that's coming in with large blocks that are megabyte and larger that can be very efficiently written to platter. But then you've got these metadata writes for the file system that are very inefficient. So what the metadata offload, those SSDs, they have to be mirrored, but what they do is they say, hey, anytime I have a small write, every time I've got some metadata write for the file system, put it on SSD. And now those things can be done at very fast rate, hundreds of thousands of IOPS, depending on what the speed of the underlying hardware, the flash media is. But it will in turn boost the overall performance of the throughput, because now all of the throughput to the platter, the hard disk drives, is going to be large block sequential. So that's an important element for archive configurations. Should always have a pair of SSD drives for metadata offload. Okay, so now we've talked about the server build and the media. The last part of the server build is the amount of RAM. Now, the amount of RAM that you need is kind of varies with the size of the configuration. So as the number of disk drives increases, we generally increase the total amount of RAM in each server by a ratio of 1 to 1 in some cases, where it's for every terabyte of storage, you get 1 GB of RAM. But in very large configurations where it's largely ingest, a lot of archive, you don't need to have that 1 to 1 ratio. And that's why this ratio here you can see is at 0.5. That means that even though this configuration has a raw capacity of 1.4 roughly petabytes, we don't need a terabyte of RAM in here. And so the general recommendation is to put it at 0.5 for a archive configuration, and for something that's like virtualization and databases, you might want that to be 1 or greater than 1. So as an example, let's say you had a 100 terabyte configuration, you would, instead of putting in 100 gigs of RAM for a virtualization config, you might increase that, take that up to 192 gigs of RAM. So just keep that in mind. High IOPS, workloads that could lead to a lot of churn of data, fragmentation, increase the amount of RAM. Workloads where it's going to be mostly sequential, large ingest, archive type use cases, you can reduce the amount of RAM to maybe a ratio of 0.5, about half a gig of RAM per terabyte. And so here at this, you can see what it set it to in our server specification. It says 368. If I was to go and increase this slider, you can see if we take it up to 2 to 1, it's there, and so on. So yeah, in this case, kind of a good one would be setting would be 0.6, and then we've got 384 gigabytes, and the usable capacity here is 912 terabytes. We're going to divide that by 2 and have 450 terabytes per pool, and then each pool, pool 1 would be active on the first server, pool 2 would be active on the second server, and that way you've got both servers active at the same time. But you have to keep in mind, if you turned off one of the servers, it's going to move that pool, it's going to migrate it back to the other box, and so you could have both pools on the same server at the same time, so you need to plan for that. So yeah, in general, a 1-to-1 ratio is a good ratio to go, but you can back that off and reduce it to something between 0.5 and 1 for a archive-based config. Okay, so that's the server build. Let's talk about a little bit about configuring the storage. When would you use these different parity-based configurations? And this came up in the ZFS Developer Conference this year. There's a great video, or rather blog article by Matt Ahrens that we'll put into the description about parity-based using RAID Z. But in short, you can use any combination of data and parity, and we've put in the most common ones right here into the design tool. For virtualization type workloads, you really want to go with the mirrored, the RAID 10 type configuration. That's going to give you the maximum IOPS. For sequential throughput type workloads, that's when you're going to want to look at using the parity-based configurations. The parity-based configuration that has the fastest rebuild speed is 4D plus 2P, 4 data plus 2 parity. And so that's why we use that as the general backup and archive, very fast rebuilds. But say it's a cold archive, say you don't need to worry as much about having the rebuild be real quick. You can use a triple parity. In fact, with triple parity, you have even more time for a rebuild, because you could have 3 simultaneous drive failures per stripe with no data loss. So yeah, so single parity, 2D plus 1P, that could be useful for a flash configuration where you're trying to get a little bit more usable capacity out of it. 4D plus 1, we generally don't recommend that because there's not enough protection there. We generally recommend that everything is double parity or better. In the double parity options, you've got 4D plus 2, 8D plus 2, 6D plus 2, all of those are good options. 8D plus 2 is going to give you 80% efficiency. So if I choose that, the total usable capacity is 80% of the raw. So for every 10 terabytes of raw capacity we put into this configuration, we're going to get 8 terabytes usable. So that's a little bit about these parity selections. And as you select them, you'll see that usable capacity ratio on the right. So for X amount of raw, this is how much is usable. Let's talk a little bit now about some of these other adjustments. By default, compression is turned on by default with all QuantaStor pool creations. You can turn it off. The data compression should be left on even if the data is not compressible. And that's because the efficiency of how it goes and writes data to disk goes up. So you're not just getting a benefit from, is the data compressible, but it's also about all the metadata and the technique by which ZFS writes the data to disk. So even if you set compression to 0 here, because you're not going to be able to compress the data, inside of QuantaStor, when you create the pool, leave it at the default. Let it use the LZ4 compression. It'll detect when the data is not compressible and then not compress it. You don't really need to worry about tuning that. The next bit is this reserved free space. And for virtualization and databases, you really want there to be a good amount of reserved free space so that as the file system fills up, that it has plenty of space to find free extents to go write, essentially having these blocks that are unused that it can access easily and keep the performance up. If you let a file system, pretty much any file system, fill to 90+% full, it'll have a hard time finding holes. Basically, it's empty free blocks, and it can spend a lot of time just looking and hunting for free blocks to go write new data to. And that'll overall slow down your write performance. So keep in mind, keep the used space in your pool typically below 80%, and you'll do well. And the other thing to keep in mind is that when you get close to 70% full, you should be expanding the pool at that time and adding more drives to make it so that you get a nice balanced expansion of the pool and maintain that performance as the expansion takes place. Waiting till you get 99% full and then adding capacity makes it very difficult to maintain performance in the process. So this reserved free space, basically it goes and adds capacity to this configuration that will just not be used. If I go and I reduce this, sure, it's going to reduce the raw capacity calculation here, but you want to kind of keep in mind, hey, if you need a petabyte, go ahead and make it so that it has an extra amount of space here, in this case 10%. So you can see the usable capacity calculation in the solution summary is 1.1 petabytes, and that's to account for this need for extra space to maintain the efficiency of the storage pool. All right, and the last bit here in the storage configuration is reserving drive slots. Let's say you need to go and handle all the capital expenditure of the servers and JBODs up front, and then you want to be able to expand this system, or maybe you need to set this up as 1 petabyte across 2 sites. What we can do then is we can just say, hey, reserve 50% of the drive slots. And what this is going to go do is it's going to go and double the configuration for us. So now the hardware has doubled, but the overall capacity is the same. So now we can think of this as 500 terabytes in the first cluster, 500 terabytes in the second cluster. And this is a nice, quick little hack. It's nice for setting up or designing a solution that is for a primary site and a DR site. QuantaStor includes all of its features in every edition, including HA and DR remote replication. So there's no additional add-on costs, and that kind of takes us down to the license summary. Inside of the tool here, if you talk we don't sell hardware at OS Nexus, but as you talk with your hardware reseller, one of our channel VARs or distributors, they can help you with some pricing information so that you can go and input that into the design utility here, and then that will go and calculate the overall hardware price per terabyte. So I mean, I'm putting zeros in here, so it's not going to give us a good number, but once you get this information, you can input it into the tool, and then that's really helpful for sizing and getting a better idea of what the price per terabyte is. We do provide some software price per terabyte information based off of our MSRP pricing, and you can go and adjust that here. You can say, hey, what does it look like with a 5-year silver? And you can see that our software price per terabyte gets down to around $12 per terabyte per year. This is based off of OS Nexus 2020 pricing. And if you click here, it'll send us this information from the design tool so that you can get some pricing information from us, or we'll most likely be connecting you with one of our reseller partners. The last bit I wanted to mention is that when you are designing solutions, one of the great things about this design tool is that you can go up here into the URL and select that design and copy and paste that into an email and send it to a friend. So if you're working with a client, the VAR, you can take the ideas that you have for a design, share it with them, and really collaborate together on getting a great solution designed. One last bit I wanted to finish on. QuantaStor has a free trial edition you can access from our website. If you click here and fill out the form, you can just choose how many license keys, and we'll send you those license keys. The trial edition license keys have 256 terabytes max capacity. The community edition has a 40 terabyte max capacity. The community edition is a version of QuantaStor that's exactly the same as our enterprise edition, but it's capacity limited and the grid size is limited to a 4-server grid. I encourage you to try it. If you have any questions, please write us at support@osnexus.com if you need some assistance setting up a configuration. Thanks for watching.